Good afternoon, students. In the last class, we have started with the chapter that is atoms. So, in the second part, this atom chapter is there. In this chapter, we have discussed that is J.J. Thomson model and Rutherford alpha ray scattering. Right? After that, we have discussed what is the distance of closest approach and impact parameter. So, these four concepts we have covered already. So, let us see the next concept in this, that is Rutherford's atomic model. We have Rutherford atomic models. According to Rutherford, what was the assumption of his atomic model that we will discuss today. Okay. So here, according to Rutherford, here we have four assumptions. The first point, according to Rutherford, is so what he will say. He will discuss that whatever the electrons are there, he will say the electrons are revolving around the nucleus, and this nucleus is heavily positively charged. That is mass that is concentrated at the center. So according to the Rutherford, he will say that every atom consists of a nucleus. This nucleus is made up of heavy, massive positive charges. So that is called as the nucleus. That is the first point. Then the second point, what we will say, all the electrons are revolving around the nucleus. All the electrons which are negatively charged, they are around the nucleus. They are revolving around the nucleus in a circular orbit. In a circular orbit. That is the second assumption. So what is the first point here? The first point is all the positively charged massive particles are concentrated at the center. That is called as the nucleus. And the second point is all the electrons which are negatively charged revolving around the nucleus in a circular orbit. So here what happens? The number of positive charges and the number of negative charges are equal. Therefore, we say that atom is electrically neutral. Therefore, we say that atom is electrically neutral. This is the second point. Then what is the third point here? The third point explains that the size of the nucleus, is of the order of 10 raised to minus 15 meters. The size of the nucleus is of the order of 10 raised to minus 50 meter, and the size of the atom is of the order of 10 raised to minus 10 meter. Okay, so this is size of the nucleus and this is size of the atom. So within atom you have nucleus. So here you can see. So this is how much a smaller particle or the smaller massive body inside the nucleus. So this is size of the nucleus. Size of the nucleus. This is size of the atom. This is his third assumption or the point is here. And the fourth last point is, as you know that electrons are revolving around the nucleus in a circular orbit. You know the concept, when any body is moving in a circular orbit, it experiences necessary centripetal force. So this necessary centripetal force is provided by the electrostatic force. Do you remember what is electrostatic force in case of atoms? So what I am saying, all the electrons are revolving around the nucleus in a circular orbit. When the electrons are revolving around the nucleus in a circular orbit, that time here what happens? Whatever the necessary centripetal force is there, that is provided by the electrostatic force. So what is the expression for centripetal force? Centripetal force is given by m v square divided by r. Centripetal force is given by m v square divided by r, which is equal to what I am saying. It is provided by the necessary electrostatic force. So what is the expression for electrostatic force? It is 1 divided by 4 by epsilon naught z e square divided by 1 divided by 4 by epsilon naught z e square divided by r square. Okay, so this is what the necessary centripetal force is provided by the, that is electrostatic force. Simplify this equation for radius of the whatever the circular orbit you are considering. So how you will solve it? I'll just simplify it for r. How you will simplify this r will get cancelled. So what I can do, I can take this r on the other side. Therefore here it becomes r is equal to 1 divided by 4 by epsilon naught. This is z e square divided expression for radius of the atom. The expression for radius of the atom. 1 divided by 4 pi epsilon naught. It is a constant value. That is 9 into 10 raised to 9. Then Z. Z is what? Atomic number. For hydrogen, you know the value. For hydrogen, what is the value here? For hydrogen, we have Z is equal to 1. For hydrogen, we have Z is equal to 1. That is Z square divided by mv square. So you can substitute all the values, calculate the radius of hydrogen atom. Here I am just taking Z is equal to 1. If I take Z is equal to 1 and if I substitute all other constant values, or if you simplify this, you can take it as R is equal to 1 divided by 4 by epsilon naught. Z is equal to, I am taking 1. Therefore, this is V square divided by V square. So this is the expression for radius of hydrogen. This is the expression for radius of hydrogen atom. So if you know any other molecule or any other atomic number, you can substitute the answer for radius of that particular atom. Am I clear? So we have 4 points for the Rutherford atomic model. First one, heavily positively massive particles are at the center, that is called as nucleus. All the electrons are revolving around the nucleus in circular orbit. So in that circular orbit, those are negatively charged one and the nucleus is positively charged. Therefore, the atom is electrically neutral. Third point, what is the third point here? The size of the nucleus is 10 raised to minus 10 meter. Size of the atom is 10 raised to minus 15 meter. Then the fourth one point is the necessary centripetal force for the circular motion of the electron is provided by the electrostatic force of the atom. So if you simplify this, you will get R is equal to 1 divided by 4 pi epsilon naught, Z is square divided by mv square. Here you can substitute the value of Z for different atoms. I have taken for hydrogen, answer is R is equal to 1 by 4 pi epsilon naught E square divided by mv square. Is it clear? So very simple concept here. So this is 2 mark question. Rutherford's atomic model. Explain Rutherford's atomic model. Then here, whenever any theory is given in physics, we will see whether it is applicable or working under all the conditions. All the theory is valid for this or no. So here, Rutherford will fail to explain 2 concepts. Therefore, Rutherford model will fail. Which 2 concepts he could not explain, that we will see. So what you can say, the limitations of Rutherford's model. What are the limitations of Rutherford's model here? First limitation is, you know that electrons are continuously revolving around the nucleus. Correct? So if it is continuously revolving around the nucleus, from where the energy will come? Right? Suppose if you are studying from morning to evening continuously, from where you will get the energy? You will have tea, you will have snacks, you will have food. From where you will get the energy? That energy you can convert it into work. Here, similarly, when electron is continuously revolving, from where it will get the energy? Here, if it is continuously revolving, if the energy it is spending, if that energy is over, why it will not fall into the nucleus? Why it is continuously revolving? From where the energy comes? So this question was not explained by Rutherford. So this is the first drawback you can see, or the first limitation of Rutherford's atomic model. What is that? From where the stability of the electron comes. Stability of the electron he could not explain. What is that stability of the electron? Means here, from where the electrons are getting the energy, if that energy is continuously getting supplied, if that energy is over, why electrons will fall into that? Fall into the nucleus. It's the first limitation. Second limitation, if this electrons are giving you continuously energy, then you should get continuous spectra. You should get continuous spectra. But if you observe the spectrum of the atom, it is a line spectrum. So what is line spectrum? We will discuss that later. So here the atom will give you the line spectrum, but here when the electrons are revolving continuously, it should give continuous spectra. So Rutherford model could not explain why atoms are giving you line spectrum, not continuous spectrum. So he could not explain that. These are the 2 there, if they are revolving continuously, why it is not giving you line, that is continuous spectrum, why it is giving you line spectrum? That is also, it could not explain that, therefore the result will fail. I hope it is clear to everyone. Rutherford's assumption or the model we have discussed and the limitations of Rutherford's model. Okay. Then next we have, that is atomic spectrum. So what do you mean by atomic spectrum? What are the types of atomic spectrum? Let us discuss. So here, when any atom at low pressure, so we are going to discuss the next concept is atomic spectra. So what is this atomic spectra? What it explains here? Here your whatever the atom is there, when it is subjected to low pressure and when it is subjected to the electric, that is passing the electric current, when you pass the electric current and when it is subjected to the low pressure, it will give you some line spectrum. It will give you line spectrum here. So if you observe this line spectrum of hydrogen atom, what I am saying, try to understand that. If you observe the line spectrum of hydrogen atom, मतलब आप hydrogen atom लोगे, you are maintaining at low pressure and passing the electric current through that. So if you do this, what you can say, activity or the performance or the experiment here, you are getting some wavelength here. You are getting some spectrum of particular wavelength. So what is the range of that wavelength that you can see? So here you are getting the wavelength of the range 66.3 nanometer. Nanometer means 10 to the minus 9. Then 486.1 nanometer. Then 434.1 nanometer. Then 410.2 nanometer. So here this is the range of wavelength. This is called as what? That is hydrogen atom will give you. Hydrogen atom will give you these series of wavelength when hydrogen atom is subjected for electric current under low pressure. So this whatever the range you are getting, this range of wavelength or the series is known as what? Balmer series. This is known as Balmer series. Why it is called as Balmer series here? Because Balmer will identify this fact, that is when hydrogen is giving you a spectral line, that time it consists of these all wavelengths. Therefore, it is called as what? Balmer series. Therefore, it is called as Balmer series here. So, Balmer will explain this series of wavelengths, and to conclude or to study the nature of all the wavelengths of different atoms, he will give one formula. What Balmer will do? Balmer found a simple empirical formula for the observed wavelength. He will observe this wavelength, he will give some empirical formula. Means some formula he will give to calculate the wavelength. So what is the formula here? Formula is something like this. It is 1 divided by lambda is equal to r into bracket. 1 divided by lambda is equal to r into bracket. 1 divided by 2 square minus 1 divided by n square. So this expression was given by Balmer here. That is the wavelength of the particular spectrum is given by r into 1 by 2 square minus 1 by n square. This is known as what? Balmer series. This is known as Balmer series. As the wavelength includes different series, that is given by, so here we have 5 series of wavelength, that is Lyman series. The first series we call it as, first one it is Lyman series, and the second one it is Balmer series, and the third one it is Lyman series, Balmer series, and the Passion series. Then the next one it is peak one. Then the next series we have bracket, and then next peak one. Bracket series, and the last one we have is peak one series. So what we will say here, that is whatever your series of spectral line is there, it comes under these different series here. The first one is Lyman series, then Balmer series, then Passion, bracket, and peak one series. So here, what is the formula 3, 4 and 4. Are you getting my point? In case of Lyman series, the formula for lambda is 1 by lambda is equal to r into the case 1 by 1 square minus 1 by n square. For Balmer series, it is 1 by lambda is equal to r into the case 1 by 2 square minus 1 by n. Then for Passion series, it is 1 by 3 square minus 1 by n square. Then bracket 1 by 4 square minus 1 by n square. Then for P form it is 1 by 4 square minus 1 by n square. So here what happens? This value it increases 1, 2, 3, 4, 5 ऐसे होता जाता है. Then n value for Lyman it is starting from 2. For Balmer it is starting from 3. For Passion it is starting from 4. ब्रैकेट फॉर 5 p फॉन्ट फॉर 6. मतलब इधर जो वैल्यू इंक्रीज होते जाता है इधर n का वैल्यू भी वैसे इंक्रीज होते जाता है. लाइमन को इधर 1 here 2, for Palmer 2 here 3, then for Passion 3 4 like that. So this is how you can write this spectral series, and where here we have written r. What is this r? R is known as the constant value. That constant is nothing but Rydberg constant. R is known as it is Rydberg constant. What is the value of r? It is 1.09 in 10 raised to 7. So r is known as it is Rydberg constant. Its value is found to be 1.09 into 10 raised to 7. Important because from atom chapter you will get some numerical sums. This is the same formula. You should remember all the series here. So based on the series, your n values, n1, n2 value you should remember, and r is must be. Is it clear, everyone? So this is how you can calculate the atomic spectra and its whatever the wavelength is there. Then next we have some concept called as what do you mean by wave number. What is Bohr atomic model? Here till now we have discussed for Rutherford. What is Rutherford atomic model? Rutherford alpha ray scattering, Rutherford's limitation, why it will fail. After failing that we will get the Bohr's model here. So what Bohr model will explain, that we will discuss in the next class. So Bohr's atomic model is the next concept. Okay, so I hope it is clear.